Hello, this is the luckiest maths teacher in the world. Thank you again for watching. This time we go through using equations to solve problems. So basically what's going to happen here is you're going to be given a worded problem, a whole bunch of words. You have to make that into an equation and then solve it. So we'll do it by following these steps. So the first step you have to do when you're solving these problems is define your variable. Now by variable, we mean something that varies from question to question. We're just talking about the pronumeral or the letter. So what we do is we say let x, or really any letter's fine, let x equal whatever you're trying to find. So if the question's asking, about a certain number, we let x be the number. If, say, the question was asking for an amount of money, we would let x be the amount of money. So just let it be whatever you're trying to find. So then the second part, what you're going to do is you're going to form an equation. So what we're going to do is we're going to take a whole bunch of words and make them into an equation. So we basically rewrite the information we're given, but only using mathematical symbols and a pronumeral. You should only use one pronumeral. So we'll go through that when we're doing a question, and after you've done that, once you've got to the form an equation stage, it's just like all the others we've been doing for so many lessons. So the last step is you solve it. You should solve it, if it's a worded problem, by having a worded answer, and I'll show you what I mean. But it's really number 2, that is the hardest step in this. So let's go ahead and look at an example following these steps. So let's look at this question here. A taxi driver charges $4 to come out plus $3.20 for each kilometre travelled. How far could I travel for $100? Now we don't want to just use trial and error, try and figure out how many kilometres I can travel for by guessing all the time. We want a way that's going to come up with the answer. And that's why we're using equations here. It's not something you're expected to be able to do in your head. So we're going to follow the steps I put up on the previous slide. So the first step is we want to define our variable. So I'm just going to call it x. You can use any letter you want. Let x equal what we're trying to find. So we're trying to find how far I could travel for $100. But that's not precise enough when we're talking how far. We want x to be the number of something. So in this case, x is going to be the number of kilometres I could travel, because we're essentially finding out in this question, can I go for 1 kilometre, 20 kilometres, whatever. We're using kilometres because they were the units given to us in the question. So that's first step done. I've defined my variable. Now the second step is I want to rewrite this information here into an equation. You can't write everything there. You have to pick out the important information. So let's look at the question again. It says a taxi driver charges blah, 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 and then how far I could travel. It doesn't matter whether it's a taxi driver or not. It wouldn't matter whether I said limo driver or it said, a plane company, a car company, whatever. So the taxi driver bit, although it gives us some context, it really doesn't affect the question at all. So I don't need that information in my equation. Okay, so I'm going to rewrite the other stuff there. So what I'm saying is I'm going to travel and I'm going to pay $4 plus $3.20 for every kilometre I travel, because x is the number of kilometres, and I want that to equal $100. This here says the same as this information here. It just says it more succinctly. So this says $4 plus $3.20 per kilometre equals $100, and I have to figure out what value of x makes this true. What is the number of kilometres I travel that makes this a true statement? So once we've got the equation here, it's much, much easier because it's just like everything we've been doing in previous lessons. So the third step is I'm going to solve it. So even though there's a decimal here, don't think that we do anything differently. We just undo everything that's been done to x already. We can use the balance method or flowchart method, either, I don't mind. I'm going to use the balance method. So first thing I need to undo is adding 4, because this here is a positive 4, so I need to subtract 4 from this side so they cancel each other out. But what I do to one side of the equation, I have to do to the other. So I've got to subtract 4 here as well. Okay? You can do whatever you want to one side of the equation, as long as you do the same to the other side. So on the left-hand side of the equation, I'm just left with 320 times x equals, so 100 minus 4 is just 96. So now, as I said before, yes, there's a decimal here, but we don't treat it any differently. This is 3.20, $3.20 times x. So we undo timesing by dividing. So we're going to divide each side by $3.20. And you can use your calculator for that. You should get the answer x equals 30, right? So as I said before, we should give a worded answer. So therefore, you just say, I could travel, because what we were trying to find is how far I could travel. I could travel 30 kilometers for $100 at this price. Okay, so what we've essentially just figured out is that if a taxi driver charges $4 to come out and $3.20 per kilometer, I can travel 30 kilometers and pay $100 for that. So the question is now done. I've solved it. I've found how far I could travel. Now we're going to look at an example that is a little more complicated. So pause and copy this down if you need. So we'll try this question now. My dad is 1 more than 3 times my age, and the sum of our ages is 57. We have to figure out how old each of us is. So we're going to follow the same steps. First step we need to do is define the variable. Now some people might get a bit confused from this question because you're sort of finding two things here. You're finding my dad's age and my age. So when that happens, you can't use two different variables. We can't say let x equal my age and y equal dad's age, because we can't solve a linear equation that has two variables. There will actually be infinitely many answers to that. We can only ever use one variable, one letter. So what I can do though is I can let x equal my age, but when I find my age using equations, I can easily find my dad's age from that because he's 1 more than 3 times my age. So I'm just letting x equal one of the things I'm trying to find. Second step, what we want to do is we want to put this information here into an equation, okay? So again, there's some information that's not needed, it doesn't matter whether the person's my dad, uncle, friend, whatever. We don't need to put that in the equation. So what we're going to say, my age plus my dad's age equals 57. If my age is x and my dad is 1 more than 3 times my age, he is 3 times my age plus 1. So my age plus dad's age equals 57. That's how we do it. So we've still only got one variable, one letter in the equation, which is good. So before we solve that, we might just tidy it up a bit because x and 3x are like terms. Remember, you can't add 3x and 1 together to get 4x. They are not like terms. But x and 3x are both like terms because they both have an x there. So x plus 3x is 4x. So we have 4x plus 1 equals 57. In other words, 4 times my age plus 1 equals 57. Now that we've got to that stage, it's easy because you've been doing this so much. So we take our equation and undo everything that's been done to x in the opposite order to BODMAS. So I subtract 1 from both sides. I've got 4 times x equals 56. So instead of timesing by 4, I need to do the opposite and divide by 4. So 56 divided 4 is 14. So I have found my age. So therefore I am 14 years old. You can just write I am 14. So my dad would be 3 times my age plus 1. He would be 1 more than 3 times 14. So he'd be 3 times 14 plus 1, which is 43. So I'm 14, my dad is 43, our ages add up to 57. Hope you found that alright. Please ask me any questions if you find it confusing. Other than that, this has been the luckiest maths teacher in the world. Have a great day.